Hi everybody. So this is the third example video of using the epsilon delta proofs with quadratic functions. Okay, this one is a little bit different. So even if you watch the other two, go ahead and stick around. So the first thing we're going to do is write out the definition for this example. So for every epsilon greater than 0, there exists a delta greater than 0 so that x minus a less than delta implies f of x, which is x squared minus 2x plus 2, minus L is less than epsilon. Okay, so now we are going to pick our delta value. Okay, so we're going to do that by looking at what we want to be true and forcing that to be true. Okay, so x squared minus 2x plus 2 minus 1 is less than epsilon. Okay, so I'm going to combine these two. Okay, and then I'm going to factor. Okay, now you can see this is a little bit different than previous examples because we have both of the factors being x minus a, right? So before we had one factor that we knew we could bound with delta, but another factor that we had to control using a trick. Okay, here we're having that both factors are bounded by delta. So what we're going to do here is use this property of absolute values that says the absolute value of the square is the same as the square of the absolute value. Okay, so now because the function that's the square root function is increasing, we're going to take the square root of both sides. Okay, all right. Now we need to know that the square root function is increasing to know that we're allowed to take the square root of both sides without flipping the inequality symbol. Okay. All right, so that's going to allow us to pick our delta. Okay. All right. So let's look at our proof. Okay, again, it's going to look a little bit different because we have two of the same factor instead of two different factors. Okay, so we're going to start the same way. Let epsilon greater than 0 be given. Okay, and then we're going to say what our choice for delta was. So we're going to let delta equal square root epsilon. Okay, this is well defined because epsilon is always a positive number. Okay, so then we're going to start with the value that we want, right? Or the value that we know is true, which is that x minus 1 is less than delta. Okay, and then we're going to replace delta with the value that we've chosen for delta. Okay, now what we really want here is to square both sides of this equation, and we are going to do that, but what we need to do is explain why we're allowed to square both sides and why that doesn't mess up our inequality symbol. Okay, so we're going to say since x squared is increasing, right, when x is greater than 0, and absolute value minus 1, okay, and root epsilon, okay, are greater than or equal to 0, we can square both sides. Okay. So when you square two positive numbers, the smaller one is still smaller and the larger one is still larger. That's what it means that the function is increasing, right? If you put in a smaller number, the output is smaller than if you were to put in a larger number. Okay, now that's not true for negative numbers. For example, -3 is less than -1, but if you square them, you get 9 and 1 where the other one is larger. So it is important that both of these values are non-negative values. Okay? All right, so now we know we're allowed to square both sides, so we're going to go ahead and do that. Okay, so this is the same as x minus 1 squared, using that same property as earlier. Okay, and over here, square root of epsilon squared is just epsilon. Okay. Multiply this out. And then we're going to write this in the f of x minus L form. So this is going to be x squared minus 2x plus 2 minus 1. Okay, and since f of x minus L is less than epsilon, we're going to conclude by definition. Okay, the limit as x approaches 1 of x squared minus 2x plus 2 is equal to 1. Okay, so again, this is a little different than the two previous examples just because we ended up with this repeated factor. And I wanted to do this example because it's so important to state why you are allowed to square both sides, right? Because it's not every operation that you can do to both sides of an inequality, right? Different than an equal sign where you can do the same operation on both sides. An inequality, there's really only certain things that don't change the inequality symbol. Okay, so we do have to state a reason, okay, and it's because both of these values are positive, okay, and the squaring function is an increasing function, okay. So I hope that example makes sense, and I'll see you guys.